All right, let's talk about something we've all probably seen by now. You ask an AI a question, and it gives you an answer with total confidence that is completely, 100% made up. We call this an AI hallucination. But what is it, really? Why does it happen? And the big one, can we ever actually fix it? Well, today, we're going to break it all down. So here's our game plan. First, we'll nail down what an AI hallucination actually is. Then we'll look at the real-world stakes. Sometimes they're funny, but sometimes they're downright frightening. After that, we'll dig into the mechanics of why these things happen, check out the tools being built to stop them, and finally, we'll tackle the great debate. Are these hallucinations just a bug we can squash, or are they a core feature of how this tech works?
Okay, first up, what on earth does it even mean when we say an AI hallucinates? You hear the term everywhere, but let's get a really clear definition of what we're dealing with.
At its core, the question is pretty simple. Why do these incredibly advanced language models just invent things? And it's so important to understand that it's not spitting out random nonsense. The stuff it makes up often sounds totally plausible, which, is exactly what makes it so dangerous. Here's the textbook definition for you. It's when a model generates stuff that's just plain wrong or makes no sense, but it serves it up with the same confidence as a proven fact. It isn't saying, "I'm not sure," it's just fabricating information and pretending it's the absolute truth.
And this is just a perfect example of how bizarre it can get. Someone told a model that churros were good for surgery. A totally ridiculous idea, right? Well, the AI didn't just agree, it invented an entire scientific study to back it up. It came up with details about pliable dough and the calming effects of the flavor. This is exactly what we're talking about. It's not just getting a fact wrong, it's creatively filling in the gaps with pure fiction.
Look, that churro thing is hilarious, but these hallucinations aren't always a laughing matter. The stakes can go from a funny little mistake to a situation with really serious legal and financial consequences. Let's look at a few examples.
So, on the lighter end of the spectrum, you've got visual hallucinations. An AI generated a video of that famous bridge from the Harry Potter movies, but it got basic details all wrong. It added a whole extra track and had the train going on the wrong side. It's amusing, but it's not going to change the world.
But then, you have this. Air Canada's customer service chatbot completely made up a bereavement policy. It told a customer they could get a discount they weren't actually entitled to. So, the customer sued, and a court actually forced the airline to honor the policy that the bot invented. The court basically said, hey, the bot is part of your company, you're responsible for what it says. Ouch.
And it gets even more serious. You might have heard about this one. A lawyer used an LLM for legal research, and the model just fabricated several court cases. They sounded real, they had case numbers, but they didn't exist. He cited them in a real court filing and ended up facing sanctions. I mean, think about it. A profession that relies entirely on facts and precedent, and the tool is just making things up.
And this isn't some rare, one-off problem. A study from Stanford looked specifically at legal questions and found these absolutely jaw-dropping hallucination rates. We're talking 69%, 82%, even up to 88% of the time. Let me put that another way. In a high-stakes legal setting, these tools were making things up more often than they were telling the truth. Those numbers are, they're terrifying.
So that leads us to the billion-dollar question. Why? How can these systems that seem so brilliant make such fundamental mistakes? Let's peel back the layers and look at the mechanics behind it all.
Okay, this is the single most important thing to understand. Large language models are not databases of facts. They are not encyclopedias. They are incredibly complex pattern-matching machines. Their one and only job is to predict the next most likely word or token in a sentence. Their goal isn't to be true, it's to generate language that sounds like it could be true based on the trillions of examples it's been trained on.
AI researcher Gary Marcus has the perfect analogy for this. He says it's like a giant game of Mad Libs. The model is just statistically filling in the blanks. It doesn't know a fact. It just knows that based on its training data, certain words are very, very likely to follow other words in a specific context. It's all about probability, not knowledge.
And that core design creates a perfect storm for errors. Hallucinations pop up for all sorts of reasons. Maybe there were gaps in its training data, or it doesn't know about recent events because of its knowledge cutoff date. If you give it a vague prompt, you're basically inviting it to get creative and fill in the blanks. And there are technical things too, like overfitting or just losing track of the conversation because of a limited memory.
Okay, so we know it's a huge problem, and we've got a good idea of why it happens.
But it's not a lost cause. Researchers and engineers are building a whole toolkit of strategies to fight back against these falsehoods. So let's look at what's actually being done to fix this.
There are really three main lines of attack right now. The first one is simple, just giving the model better instructions, which we call prompt engineering. The second is a powerful technique called retrieval augmented generation, or RAG, which basically gives the AI a cheat sheet of verified facts. And the third is a constant process of training and retraining the model using feedback from real humans.
And something as simple as prompt engineering can make a massive difference. Look at this example. A bad, vague prompt just says, write a fun quiz about math. If the model doesn't have one ready, it might just make one up, facts and all. But the good prompt gives it a clear rule. If the user asks for something you don't have, just say so. It's about setting boundaries, and it works.
RAG is even more powerful. Instead of just relying on its own internal, sometimes flawed training data, a system using RAG first goes and looks up relevant information from a trusted source, like a company's internal documents. Then, it uses that information to build its answer, and the results are pretty stunning. As you can see here, studies show RAG can slash hallucinations by up to 68%. It's a huge step toward grounding these models in reality.
But this brings us to our final, and maybe most profound question. We've got all these tools to make things better, but can we ever really get hallucinations down to zero? This is the great debate happening right now. Is this whole thing a fixable bug, or is it just an inherent feature of how these models work?
And honestly, this is the trillion-dollar question for the entire AI industry. Because if the answer is no, if we can never fully stop them, that changes everything about how we should build, use, and trust these systems moving forward.
There's a really challenging school of thought that argues hallucinations aren't just a flaw, they're an inevitable consequence of the technology itself. Some researchers connect this to really deep, fundamental limits in computing theory, suggesting that because these models can never learn everything, they will always have blind spots where they are forced to make things up. So the debate really boils down to these two camps. On one side, you have the optimists. They see hallucinations as a solvable bug. With better data, better tech like RAG, and more human feedback, they believe we can eventually engineer our way to nearly 100% factual accuracy. But on the other side, you have the pessimists, or maybe we should call them the realists. They see it as an inevitable feature, an innate limitation we just have to live with. For them, the goal isn't elimination, it's mitigation, management, and making sure users always know the risks.
And that leaves us with one last big thought to chew on. If these incredibly powerful tools, which are being woven into the fabric of everything, from search engines to medicine, can never be fully trusted to know the difference between a fact and a convincing lie, what does that mean for us? How do we build a future with a technology whose very nature might be to confidently mislead us? That's a question we're all going to be grappling with for a very long time.